Hey guys, what's up? It's Mr. Gooden, and today we're going to talk about solving system of equations using the elimination method. All right. Now, the elimination method is a great method to use, and it's basically when you add or subtract equations to eliminate one variable. All right. The best time to use this, I feel, is when it's in standard form. All right. When it's in the form ax plus by equals c. So basically, when it's in the form, the linear form, when it's a number times x plus a number times y equals a constant. All right. Now, this little note over here, we're going to come back to this little note over here talking about if the signs are the same, we subtract. If the signs are different, we add. All right. So first, we're going to take a look at this system of equations here. Basically, we want to find an x value and y value that will make both of these equations true. All right. Now, to solve for both of these variables, we can't really solve for x and y at the same time. So we have to solve for one variable at a time. So what we're going to do is use the elimination method to eliminate one of the variables so we could go ahead and solve for a variable. All right, so if we look at this, what I want you guys to do is we're going to take a look at the coefficients of both the variables. All right, let's disregard the sign right now. Just take a look at the coefficients. Now, as you can see, these sixes are exactly the same. So this is the one we're going to try to eliminate. Now, over here at this note, if the signs are the same, we subtract. If the signs are different, we add. So in this case, as you can see, these are different signs. So what are we going to do? We're going to add these equations. All right, so we're going to add them. All right, and when we do this, look what happens. 5x plus 3x is going to be equal to 8x. And negative 6y plus 6y is going to cancel out. That's 0. And then when we come over here, negative 32 plus 48 is going to equal 16. All right, and now we eliminated y, and now we'll have only x to solve for. So what are we going to do? We're going to divide by 8 on both sides, and we wind up with x equaling 2. All right, now that we have x is equaling 2, what we're going to do is we're going to now take this 2, and we can substitute it into any one of these equations now. All right, you could pick which one you want. I'm going to go ahead, and I'm going to pick the second one, and come over here, and we're going to wind up with 3 times 2 plus 6y is equal to 48. Now again, look, we have only y to solve for. So we wind up with 6 plus 6y is equal to 48. Now we solve for y, we're going to minus 6, and we wind up with 6y is equal to 42. And then we're going to divide by 6, and y equals 7. Now, once you get your numbers, guys, your x and your y values, we always want to write our answer as an ordered pair. So this is going to be 2, 7. All right. Now, once you get your answer, guys, you should always check your answers. A lot of students, don't check their answers, which is the best thing to do. And it's real simple. When we're doing a system of equations, we're basically finding an x and y value or ordered pair that would make both of these equations true. So all we have to do is substitute them in, the x and y values, into both equations and make sure that they make both equations true. So let's go ahead and check that. So let's check. So if we go ahead and we do 5 times 2, that's our x value, minus 6 times 7. That should equal negative 32. And when we go ahead, we wind up with 10 minus 42. And as you can see, negative 32 does equal negative 32. So it checks out for the first equation. It works for the first equation. So it should also work for the second equation. Let's go ahead and check the second equation. If we check the second equation, we wind up with 3 times 2 plus 6 times 7 should equal 48. And when we do that, we wind up with 6 plus 42. And as you can see, 48 does equal 48. So it does check out, and we do have the proper x and y values. And that is our solution, guys. Now, there are 2 other scenarios that you might see for elimination in standard form. And what happens here is either you're going to have to multiply one or both equations. All right. And sometimes you may need to multiply one or both equations by a non-zero number first to make the coefficients of one of the equations are the same. All right. And then once the coefficients are the same, you can add or subtract, the equations to eliminate one of the variables. Now, let's take a look at when you may have to just multiply one. So again, we're just going to look at these. As you can see, they're both in standard form, and we're going to look at these variables. the coefficients for the variables, right? We have 2 and 10 and 5 and 3. So we want to think about basically integers. We're not looking for fractions. You could multiply fractions, but we're not going to go and make it harder for ourselves, right? We want to rather deal with whole numbers or integers. So if we think about it, it's like, can we make this 2 a 10 by multiplying by a number? Well, yeah, we can multiply this by 5. But also here, can we make a 5 a 3 or 3 a 5 by multiplying by a number? Nah. So we're going to make this 2 a 10 by just multiplying this first equation by 5. All right, and when we do this, I like to write everything over. So we're going to wind up with 10x plus 25y is equal to negative 110. All right, and since we didn't do anything to the second equation, it just remains the same. All right, now you can see that our x coefficient is the same now. And if you notice, they're both positive. So when we have the same signs, guys, we are going to subtract. All right, 10x minus 10x, 0. 25 minus 3y is going to be 22y. As you can see, we eliminated the x, and now we only have y. And when we come over here, negative 110 minus 22 is going to be negative 132. Sorry, my phone. And then from here, we're going to solve for y. We're going to divide by 22, divide by 22. All right, and you wind up with y is equal to negative 6. All right. And now that we have y, we're going to come back to one of these original equations and we're going to substitute y in. I'm going to go with the first one. So we wind up with 2x plus 5 times negative 6 equals negative 22. All right, and then from here we wind up with 2x minus 30 is equal to negative 22. We're going to add 30 to both sides. All right, and we wind up with 2x is equal to, add 30 to both sides. We're going to wind up with 2x is equal to 8. Divide by 2, x is equal to 4. So our solution is 4, negative 6. Now again, we should always check our answers. We can check our answers really quickly by just substituting these values into x and y for both equations and making sure that they make both equations true. So let's do a quick check over here. All right, so if we do 2 times 4 plus 5 times negative 6, that should equal negative 22. And we wind up with 8 minus 30. And as you can see, negative 22 does equal negative 22. So it does work out for this first equation. It should work out for our second equation as well. Let's go ahead and do that one. So we wind up with 10 times 4 plus 3 times negative 6, which equals 22. And we wind up with 40 minus 18. And that winds up being 22 is definitely equal to 22. So as you can see, this checks out, and this is our solution for our system of equations, all right? This x and y value works for both equations, okay? Now, the last situation that I wanted to talk about today is, what about when you have to multiply both, okay? Well, this is fairly simple. You'll notice that we look at these coefficients for these variables, right? And we can't make, we can't multiply a 4 by something to make it a 7, or a 7 by something to make it a 4, right? Or a 2 by something to make it a 3, or 3 by something to make it a 2. So what we're going to do is, guys, is just pick which one you want to get rid of, which one you want to eliminate. I like to, work with smaller numbers, so I'm going to look at the 2 and the 3. And I'm like, okay, so if I want to get rid of this y, I'm going to multiply this one by 3, and I'm going to multiply this one by 2. What that does is that it forces these two to become the same exact coefficient that we can add or subtract depending on whether we have, both positive or negative numbers. So when we go ahead and do this now, we're going to go ahead 3 times 4, which is 12x, plus 6y is equal to 42. And then over here, we're going to have 14x minus 6y is equal to negative 16. All right. Now, if you notice, our coefficients here, they have different signs. So what are we going to do? We're going to add these equations together. And 12x plus 14x is going to wind up being 26x. And 6y plus negative 6y, that's going to be 0. And then we got to come over here, guys, and take a look at this. we're going to wind up with 42 plus negative 16, which is going to equal 26. And then divide by 26, divide by 26, and x is going to equal 1. All right. Now, once we find our x value, we are always going to go back to our original equations, and we're going to substitute this one in for one of these into one of these equations. All right. So I'm going to pick the first equation. So let's do 4 times 1 plus 2y is equal to 14. So that means 4 plus 2y is equal to 14. We're going to subtract 4. We wind up with 2y is equal to 10. Divide by 2. Divide by 2. Y is equal to 5. So our solution is 1, 5. All right, that's our ordered pair that makes this equation, system of equation, both these equations true. All right, now we should always check our answer. So let's go ahead and check our answer. Let's check right here. So we go ahead and do 4 times 1 plus 2 times 5 should equal 14. And we wind up with 4 plus 10. And that's 14 does equal 14. That is correct. All right, and let's try the next one. We wind up with 7 times 1 minus 3 times 5. That should equal negative 8. And when we do this, we wind up with 7 minus 15. And that winds up being negative 8 is definitely equal to negative 8. Now, those are the three typical scenarios that you'll get for a system of equations. But there are 2 special cases that I wanted to talk about and finish up with today. They involve what we call no solution or infinite many solutions. All right. Now, the way this works is that you're going to go and look at a system of equations like we have here, and you're going to notice something weird that happens. All right. We go to solve this, and as you can see, we have we can make this 3 a 6, and we can also make this 4 and 8 by just multiplying this first equation by 2. And what you'll notice is that we'll get 6x minus 8y equals 16. All right, and then when we go ahead and look at the bottom, we also have 6x minus 8y equals 16. Now, whenever this happens and you see that you have the same exact equations, this is what we consider infinite many solutions, because any x value and y value that you choose will work for both of these equations because they're exactly the same. But say you didn't even notice that, and you go ahead and you start looking at this, you're like, oh, these are both the same. All right, they're the same sign, so what are we going to do? We're going to subtract. And when we go to subtract, you'll notice that 6x minus 6x cancels out, the x's cancel out, negative 8y minus negative 8y, which means minus negative means plus. These will cancel out, and you wind up with 0 is equal to 16 minus 16, which is 0. So if you ever notice that the variables cancel out and one side does equal the other, we call that infinite many solutions. All right, infinitely many solutions. All right. Now, on the flip side, something else might happen. You'll look at these equations and you're like, okay, we have almost the same thing, but you notice that this is different. And this is considered no solution. All right. 2x plus 6y equals 1, and then 2x plus 6y can equal 6. That doesn't make any sense. All right. But sometimes you might go through this and you're like, all right, hold on. Let me subtract because these are the same. So I go ahead and I subtract. And what will happen here? Look, 2x minus 2x, that cancels. And then 6y minus 6y, that cancels. You end up with 0. And then over here, 1 minus 6 is going to equal negative 5. Now the variables cancel out. You have one side, and you see that 0 cannot equal negative 5. Does not equal negative 5. If that happens where the variables cancel out and one side does not equal the other, we're going to call that no solution. All right? No solution. And that's the special cases that you may come across when working with system of equations. Okay? So guys, we went over the 3 scenarios that you might see. Just adding and subtracting the equations. You might have to multiply one equation to make one of the coefficients the same, or you might have to multiply both equations to make one of the coefficients the same. All right. Hopefully this helped, guys. My name is Mr. Gooden with Gooden's Math. And if you have any questions or you have any comments, comment below. If you think about any videos that you might want me to do in the future, write in the comments below. I will be doing videos on applications of system of equations with like more word problems. I'll be doing substitution, graphing. Just keep a lookout for those. And if anything, guys, drop a comment below, like and subscribe, and let me know what you want to see next. Thank you for tuning in. Hopefully this helped. Talk to you guys next time. Mr. Gooden, later.